All right, so what this problem asks for is the influence line for the reaction at B, and B is right here in the middle. So the simplest thing to do would be to look for my reaction at B as a function of my unit load. And I'll say that's at a distance x from the left-hand side. So can I solve for the reaction at B based on this position of the load? I think so. What would I do? I would sum moments a day.
Right.
So let's do that. So I'm going to use right-hand rule as my sign convention. And I will sum the moments at A and set that equal to 0. So about A, my unit load creates what kind of moment? It looks like negative moment has a value of 1 with the moment arm of x. So that would be 1x. And then my reaction at B creates positive moment and has a moment arm of 5 feet. So solve for the reaction at B. What do you get? Looks like you get x over 5, right? Is that it? You guys like that? Well, just plot that. So on my ordinate, I will say this is the reaction at B, so that's my influence line. I'll draw an x-axis and indicate some key points. So we'll just plot this. What happens, what's the value when x is equal to 0? It's 0. When x is equal to 5, what do I get? 1. And when x is equal to 10, I get 2. That is a straight line. So this would have a value of 1 and an ultimate value of 2. So where do I go stand, if I'm a moving load, to create the largest reaction in B?
All the way at B.
All the way over here. Let's say I weigh 200 pounds. What would be the reaction at B if I stand right here on the free end? What would be my reaction at B? It would be my weight times 2, 400 pounds. What if I moved over and stood right there? What would be the reaction at B? 200 pounds. What if I stood right here? What would be the reaction at B? What if I stood right here at 7.5? Yeah, because what's the value right there? You can interpolate it. It's just 1.5. So 1.5 times 200. So that's, I know, as I move from left to right, you can see the reaction at B will behave just like this. So again, remember, this x position, since this is an influence line, is not along the beam. It's the position of the unit load. The thing I'm looking for is just the reaction at B. So keep in mind that the item you're looking for is here, and then the position of x is what we see along the bottom.
So there is a moment between A and B if you're in that area. It's just less than the unit load, is that correct?
Say that again, Mr. Rippey.
If you're between A and B, you're creating a moment around B. It's just less than the unit load looking at it.
What do you want? You want a reaction somewhere? You want a shear somewhere? You want a moment somewhere?
All right.
Remember, we're drawing an influence line, so you have to tell me what you're looking for and at what point you want it.
Okay. We're looking at B. And if the load is between A and B, and I'm looking at the influence line that we have drawn, if we're to the left side of
Well, here I am. I'm operating here between A and B.
Yes.
So it's going to vary from 0 to 1. The reaction at B is going to vary from 0 when I'm here to 1 when I'm right on top of B. This is just for the reaction. This is not for anything else.
Right.
What if I wanted the reaction at A? if I come back and I add the reaction at A. I want to draw the influence sign for the reaction at A. How do I find that? Now I already have this term, right? I could some moments at B and get the reaction at A, right? Or I could do what? Now that I have the reaction at B, I can just sum forces in the y direction, right? Like you've done before. So if I sum forces in the y direction, make sure it's equilibrium, I have the reaction at A acting up, the reaction at B acting up, and my unit load acting down. But RB is this, so I can solve for the reaction at A. It's going to be 1 minus the reaction at B. Everybody see that? And that's going to be 1 minus x over 5. What does that look like when I plot it? So now I want the reaction at A as a function of its position x, and again midpoint and endpoint. So I simply just plot this line. So when x is equal to 0, what do I get? 1. When x is equal to 5, what do I get? 0. And when x is equal to 10, what do I get? Negative 1. Does that make sense? So it says when I stand right here, when I stand at B, there is no reaction at A. As I move over here and stand right over A, that creates the largest positive reaction, that's up. What if I go stand all the way down here on the end? It says it's minus 1. So if I weigh 200 pounds and I'm standing out here on the end, what's the reaction at A? Minus 200 pounds, which means it's the other way. So you can see it's balancing. It's like a seesaw. What if I add these two together? What do I get? At every point. Well, what is the reaction at A plus the reaction at B at every point? It's 1. If I add these two curves at every point, I should get 1. You guys following this? Okay. Let me stop that. Any questions before we move on? That's a pretty easy one, actually. All right. That took a whopping 8 minutes.